The objective of this lesson is to use composition of functions. A composition of functions is where you substitute one function into another. Now, what you need to know is that it's the function that is listed second, the one closest to the x, gets substituted into the first. So the function closest to the x gets substituted into the other function. Let's talk about the notation now that we have. The notation really comes in two forms. The one that is used primarily will look like this, where you have f of g of x. So notice that the g of x is inside of the f of x. So this one gets substituted into that one as part of the way we do the composition. Now another way this is written is sometimes they'll write it with an open circle, where this is read the same way, open circle for the between the two. It's not the letter O, or it's not the number 0. It means f of g of x, where the g of x is still the second one closest to the x. It gets substituted into the first. So this is read f of g of x is how we read it. So now let's do some examples for this to learn how we substitute it in. Use your substitution skills. For this one, f of x equals this function, h of x equals this one. When I have f of h of x, this means the h of x, this function, is going to be substituted into the other function for x. This is the input for the other function, and it gets substituted in. Notice there's a lot of x's here. You just have to remember that the x is the input. So this is where we're going to put this function as the input into the other one. So what it looks like here is you're going to take, and you're going to have negative 10, and you're going to leave a parentheses, plus 3, and you're going to put that square root of x plus 4 right there. So it gets substituted where the x comes out, this takes its place. We usually don't have a parentheses, so that's going to be a negative 10 square root of x plus 4 plus 3. So you just list it like that, where that second function, the one that's listed next to the x, gets substituted into the other function. Let's try this next one. This is f and g. We want to do g of f of x. I like rewriting it when it has this open circle notation. I like rewriting it this way so that I can clearly see that the f of x is going into the g of x. So this function here becomes the input in the other function, because g of x is further away from the x. So when we look at that, write out the 19 with a parentheses, minus 1, take out the x and put in its place the negative 10 x plus 3. That becomes the input. Now we just simplify. 19 times negative 10 is negative 190x. 19 times 3 is, that gives us a 57. And then we have a minus 1 out here. So now we're going to have negative 190x, 57 minus 1 is plus 56. So that's our final answer for g of f of x. And then this last example here, we're going to flip it, and this time we're going to have, notice that the g of x is the input for the f of x, so that gets put into the f function, So I'm going to list the f of x function here. I'm going to put -10. Where there's an x, I'm going to put a parentheses because that's the input spot. And the new input is this 19x minus 1 goes into that place for the x. So 19x minus 1. So when I multiply that out, -10 times 19 is -190x. -10 times -1 is plus 10. And then plus my 3 out there. So -190x. And then plus 13 is my result. So the main idea for composition of functions is you've got to substitute the function rule from one into the input spot into the other. The one to remember is the one that's closest to the x. That's the one that you take and substitute it into the other function.